Hey guys, now we're going to go over section 2 of your homework. These questions cover the Fundamental Theorem of Calculus, part 1, and interpreting the behavior of derivatives, integrals, as well as interpreting the behavior of accumulation functions involving area. As always, if you have any questions or need further clarification, don't hesitate to reach out. Okay, so question 1 says let h be the function defined by h of x equals the integral of x from pi over 4 of the function sine squared t dt. And then it says which of the following is an equation of the line tangent to the graph of h at the point where x equals pi over 4. So what I'm going to do is I'm going to solve for the equation of the tangent line. And you need two things to do that. You need the slope of the tangent line as well as a point on the tangent line. A point on the tangent line. Because the AP test is multiple choice, it's possible and even probable that you can solve these questions without finding both parts. So when you can save yourself time, I highly recommend that you do so. So let's start by finding the slope of the tangent line, and then we'll compare that to our answer choices. So h of x is equal to the integral x pi over 4 sine squared t dt. The Fundamental Theorem of Calculus part 1 tells us that the derivative of h, so if we can take the derivative of both sides, the derivative of h is the derivative of the integral. And the derivative of the integral will give you back the function. So we'll take this derivative for sine squared t dt. And so we'll find that the derivative of this function, right? The derivative of this integral is just going to be sine squared of x, and that's it. So now we want to evaluate this at the point where x equals pi over 4. So to find the slope, right, we need to take, because this is an equation that gives you the slope of the function at every point. We want to find the slope at one point. So I'm going to find the slope at x equals pi over 4. And so, how do I want to write this? I'm just going to go ahead and write m. And so I'll say that, that m equals the sine of pi over 4 times the sine of pi over 4. So remember how important it is to memorize your unit circle. I think that pi over 4 is one of the easiest to memorize because it's square root of 2 over 2 for both x and y. So what I'm going to get is the square root of 2 over 2 times the square root of 2 over 2. So I'm just going to get that the slope here is 1/2. So let's compare that to the answer choices and see if that helps us eliminate any. Here we see y equals 1/2, but you notice it doesn't have an intercept. Here we have y equals square root of 2x, so it can't be that, it can't be this, and it can't be this. So technically this could leave you with two different possibilities, except that this is a straight line and the function, right, the function sine squared is definitely not going to give you a straight line. So I think just from that alone, you can determine, right, because the slope here is 1/2, what your answer is. And then you can also go ahead and solve for your value of b, which you'll get is pi over 8, and you'll see that that also aligns with this answer choice. Okay, the next question kind of does the same thing. It just asks you to take the derivative of this function, of this integral, right, with respect to x. And so all you do is you take the function and now you plug in x for it, because that's the Fundamental Theorem of Calculus Part 1. So because of this, we know this to be true. And pretty much everyone, it looks like, got this. I'm not sure if here maybe we evaluated the integral, but yeah, it should be pretty simple. Okay, so now we're going to take the derivative of the integral again for the function sine t to the third. However, I want to note that you can only take the Fundamental Theorem of Calculus only works when you have d dx of any constant, it doesn't matter. I'll put a and x. And this could be, right, b and this could be b and b or whatever letters, but you notice it can't be x squared. So what I'm going to do is I'm going to use a U-substitution to change this x squared to a single variable. So I'm going to say, oops, let's go back. I'm going to say, let's let b equal x squared. So that db equals 2x dx. And normally I solve for just dx. So I would say db over 2x equals dx. But you notice here you have dx in the denominator. And some people kind of get confused about putting a fraction in the denominator. So what I'm going to do now is I'm going to go ahead and write this as 1 over dx is equal to 2x over db, just in case you find the other notation to be confusing. And then I can rewrite this whole problem. So I can say the derivative, the derivative with respect to x d dx of the integral from 0 to x squared for sine t to the third dt is equal to, now I'll say 1 over dx is equal to 2x over db. So I'm going to put 2x times d db for the integral. And while we would normally change, right, because this is when x equals 0, it doesn't really matter because it's just a constant. So I'm going to go ahead and leave it and put b here for sine t to the third dt. So now I can say that this is 2x times sine b to the third. And I won't be having a d, right? Because that just tells us the limits of the integral. And then I can plug back in for b, which is x squared, which is going to give me x to the 6. So I get 2x times sine of x to the 6. So this is the answer for the problem. And we see here that was answer choice E. It looks like the most popular answer choice was A. And I think we just weren't using part 1, we were using part 2 of the fundamental theorem. So we have to be really careful about that. The next question says, let g be a function with the first derivative given by g prime of x equals the integral from x0 e minus t squared dt. It says, which of the following must be true on the interval from 0 to 2? So note that they gave you g prime of x. And they said it equals this, which means that the second derivative equals the derivative of the integral from 0 to x of e minus t squared dt. And so the second derivative will just be e minus x squared. The second thing you need to be able to do is know what this function looks like. I believe all of these questions are calculator active, so you can use your calculator on these. And so when you put this into your calculator, you'll see that this function just looks like that, except more even than what I drew. Oof, it's never going to get better, and that's okay. So this is the second derivative. Note that when the second derivative is positive, when your second derivative is positive or greater than 0, that your function is concave up, which means that it's increasing. It's not possible for a function to be concave up and decreasing or vice versa. So that means if g is increasing, we can already eliminate choices C, D, and E, and the only difference is it concave up or concave down? So the answer choice here is that g is increasing and the graph of g is concave up. For x greater than 0, the integral of 1 over x of the integral du dx equals. So note, using the properties of integrals, that we can split this inner integral up. So I'm going to start by taking this integral. And so the integral, well, we don't need to split this up. We can just go ahead and solve this because we're not using part 1 of the fundamental theorem. So when we solve this, right, the integral of 1 over u is natural log of u. Usually it's the absolute value, but here x is already greater than 0. So then I could say the integral of xt for du u is the natural log of u evaluate at values x and t. Okay, so that's really just the natural log of x minus the natural log of t. Now we're going to take the integral of 1 over x times the natural log of x minus the natural log of t with respect to x. So this turns into, and we'll pretend the equal sign's right there, this turns into the natural log of x over x dx minus natural log of t is kind of like a constant because we only care about the integral with respect to x. So I'm going to pull that out and we just have 1 over x dx here. So then here you need to do a U-substitution. Oops. So if I were to let u equal the natural log of x, du would equal 1 over x dx. So that dx would turn into du times x. So I could change this, right? If natural log of u of x is u, this turns into u times du x over x. So those cancel out. Minus the natural log of t times the natural log of x. Okay, so then the integral of u is going to turn into 1/2 u squared. For this problem, because I don't think that they actually care about what this represents, I'm just going to say some constant. And when you take the integral, you're also going to be adding some constant. So we have plus a constant minus a constant. We're just going to put plus some constant number here. And then we have to sub back in for u. So we say the answer is 1/2 times the natural log of x, and we're squaring this function plus c. And we find, right, that that is answer choice E. And the reason why I didn't leave this the way it is because all of our answer choices had plus c. So that's what I did. The graph of the function f shown above has horizontal tangents at x equals 2 and x equals 5. And we can already see that just from looking at the graph. let g be the function defined by the integral x of 0 f of t dt. For what values of x does the graph of g have a point of inflection? So really it's asking you to understand, it's asking you to understand the fundamental theorem part 1. So they told you that g of x is some function, right, from 0 to x of another function. We don't know what that is, but we do know that g prime of x is equal to the derivative of the integral x f of t dt. So that g prime of x just equals f of x. So this is actually the graph of the derivative of g of x. It is not g of x. So they ask you, knowing this and knowing that there are two horizontal tangents, what values of x does the graph of g have a point of inflection? So really just knowing the definition of inflection points, then you can easily see that the answer is 2 and 5. The next question is really again asking you to interpret what the graph would look like. So figure above shows the graph of f. If f of x is this function, which of the following could be the graph of y equals g of x? So you need to know that f of x, which is equal to the integral of a function with respect to another function, that's not helpful. But the derivative of x, that's equal to the derivative of the integral, and that's just equal to the function. So the derivative of f of x is g of x. So this graph of f does not correspond with g of x. G of x is the derivative, and the derivative is the slope. Notice that this is a positive constant slope. It's a linear function, which means you're looking for a value that's a straight line because the slope's not changing, and that's above 0. And so that leaves you with answer choice A. Okay, this last question says, the graph of a differentiable function f is shown above. If h of x is the integral of x to 0 f of t dt, which of the following is true? So this, like the questions before it, needs you to understand the part 1 of the Fundamental Theorem of Calculus and how to take the graph of a function and then get the derivatives graph and the antiderivatives graph. So, one, note from the part 1 of the Fundamental Theorem of Calculus that this is telling you that this graph, f of x, corresponds to h prime of x. And so we can see that h prime of 6 is equal to 0. Okay, so now we have a choice. Do we want to graph the original function first, or do we want to graph the antiderivative first? So I'll go ahead and graph what I think the function probably looked like from this graph. So note that these, I guess we're going to be doing, let's do the second derivative. So when we're looking at a graph, the derivative here is 0. The derivative here is 0. And then the derivative here, right, the slope, I might say, is close to -1. And these are just approximations. Okay, and this, then here, the function's increasing, so it's positive all the way there. Obviously, this slope is going to be less than, here, I'll kind of show with the cursor. This has a smaller slope than this, so it kind of starts out small, gets bigger, gets smaller. So maybe we'll say 1, 2, and 1. Then it's 0 again, and then we'll say -1, just to be simple. Although this is definitely not, but that's okay. So we're going to start, we said, with a slope of -1, and it's approaching 0, and it's kind of like that. And then it slowly approaches 1, approaches 2, kind of goes back to 1. By here, it reaches 0. So this is the graph of the derivative of the function. Here it reaches 0, and then here we see it's negative again. So this is h prime of x, double prime of x. And at this point, we see that h double prime of 6 is greater than the first derivative at the point 6. Okay, now let's do the opposite. Let's try to graph the function from the derivative. And I'll change colors, although I already marked all over this one, but that's okay. So now we want to know, what does h of x look like? And I'll write this here. So h of x is going to be blue. And so first of all, everywhere that the derivative is negative, we know that the function was decreasing. So this function was decreasing all over here. And then the function was increasing. And so we see that h of 6 is a critical point, or a turning point in the graph. And I could say that this function, it started out with a slope of -2, then -3, then -4. So it started out maybe not as steep, got steeper, and then got less steep, all the way until it wasn't steep at all. It was at 0. And then it has a positive slope. So then it starts increasing slower, then faster, and then slower again. So I'm going to start at 2, but we really don't know where it starts. And let's say I had a slope of -2. And then if I had a slope of -3, I'd be really far down here. But we really just want to show that we have a function, and it's kind of fast, but it's not turning yet. So actually, I might have made my function way too big, but that's okay. It slows down, but it's still decreasing, and it's going to keep decreasing all the way to 6. And then it's going to turn into a turning point. And then the slope will start increasing. So this is obviously a very rough draft of what h of x looks like, but we can see that h of x is even smaller than h prime of x. And so that leaves us with answer choice A for the very last question. So I hope that made sense. I know that graphing from the derivative and the antiderivative takes a lot of practice. So my biggest recommendation for all of you is to practice graphing the derivative of functions and vice versa. And that's it for this video. Thank you so much.